Well, yes, good afternoon, everybody, and thank you for joining today. I'm so excited to be here with you, and thank you for being part of this experience. My name is Alejandro Mundo, so thanks, Barbie, for that introduction. And just like you have heard, I'm currently in New York, in the Bronx, New York, Kingsbridge International High School. I also work at the Climate Change Research Initiative. So I guess I'll start by telling you a little bit about myself, and then we can get into that unit plan that we have talked about. So I'm a geophysicist as well. So my career, my degree in geophysics, and also an earth science educator. So some of the things that I enjoy to do is actually I like to travel and get to know new places, although, it has been limited in the past few months because of the current situation. But I also enjoy hiking, camping, baking, also stargazing, just some things that I enjoy doing. I think it's just, so I have been involved at the Goddard Institute for Space Studies, which is in New York City, as well as becoming there. I'm the educator and also an associate researcher, as well as an earth science educator and leading the science department at the school where I am, which is Kingsbridge International High School. So it's such a great opportunity to know that, ever since I was a kid, when I was a boy, I also always got interested into science. And like you can see here on the first column on the left, so that goes back to when I was a kid. When I was a boy, I was really interested in science. And then as I grew up, I got so interested, kept going, for example, in Yellowstone. And so that's a Geisel right there. So I actually became a geophysicist, and then I was given this opportunity to study a master's at the American Museum of Natural History. So you can see on the second column that's actually outside where I got my master's there. I graduated there. And then, so one of the things that I truly enjoy, it's just the opportunity to do research, scientific research. So this is great. So as you can see here on the third column, the good thing is that I got to do some just geological research in the middle of New York City. So as you can see there, we were studying the metamorphic impacts and how the rate of metamorphism in the formation of Manhattan, and as well as some of the fossils on the picture at the bottom that we were just looking for some fossils. So I have done a big inspiration in my life. It's doing research, but it didn't stop right there. I wanted to keep going. I wanted to take it to the next level, and I wanted to bring it into the classroom. So then I became an educator, and that's how I became an educator. And that's one of the things, as you can see here in the last column. Notice that here's a picture when I wanted to inspire students, the next generation of students, to be inspired and into STEM, get into science, technology, engineering, mathematics. And this is actually through inquiry-based experiences, lab-based experiences where students can actually get interested in doing science. So over the time, let me just tell you that I have been in the classroom. I've been teaching for about 4 years in New York City. But also this is actually my second year with NASA's Climate Change Research Initiative at CCRI. And also, just to let you know that I just published this STEM unit plan as of this year, and which I'm going to definitely talk to you more about in a moment. So let me tell you a little bit about my school. So when it comes to my school, this is Kingsbridge International High School, and it has a population of about 500 students. This is actually a 100% newcomers school. Notice that I teach earth science and astronomy, and mainly to 11 and 12th grade students. The students who actually are in our school, they actually are learning English. So there's about 90% of them are learning English. And notice that about 99% of these students, they actually come from low-income families. So we're talking about a Title I school setting here where about 90% of the students are actually Hispanic. And then we got Asian, Black, and White. Those are about 3%. And other, which is about 1%. So when it comes to this, notice that we're talking about this population of students that I always try to bring in this diversity and promote diversity into my students. A lot of the times, because this is actually newcomers, students who just came to the country, to the U.S. in this case, notice that they probably don't know the language, or they have not been experienced, or they have not experienced any of these scientific learning experiences from where they come from. So I think it's so powerful to inspire and motivate our students where they are, and regardless of the experiences that they have had or probably have not had, so they can actually eventually get inspired, so they can get into a career that reflects STEM. So talking about that, in fact, let me just tell you that some of the stories that we have been featured in media stories. So as you may be aware, as of this year, for example, Perseverance, which is a rover from NASA, it landed on Mars. And so one of the things, we have been featured in different news. So for example, News 12 on the Bronx, and also other media outlets, as you can see here. So notice that these are opportunities where you can get to learn more about. So this actually serves as a motivation, since they are recognizing and they're looking at how students can, they're growing in their mindset and eventually get inspired to do that. So notice that as we go through here, let me just tell you that when we go through that, we actually, the pandemic has been, it has hit our school system throughout the whole world, but it didn't stop right there. So notice that when we look into that, here's some images that we have, for example, students doing some research, students participating, whether if it's like calculating the density of objects or getting into more analysis of climate and just carbon dioxide levels, as you can see here. So we still do science. We're still doing research in pandemic times, which I think it's so powerful that it didn't stop. It doesn't stop, which, there's pandemics, we have to stop. No. So the cool thing about this is that we don't have to stop even in pandemic times. So this is just a representation of what this represents. So let me tell you a little bit more about a little bit more about.
Okay, it looks like he got kicked out. We'll give him a second here. There, he's back. And then Alejandro, you'll have to re-cue your mic if you can hear me. There we go.
Okay, so you can hear me, right?
Yes, and just so the participants know, when he first starts, I know it's a little choppy, but it will clear up. Go ahead. Back to you.
Thank you. So let me tell you a little bit more about the program. So this program, it's from the Goddard Institute for Space Studies and Climate Change Research Initiative. That's what it's called. This is a program which it's pretty much a vertical model. This vertical model, it works with the scientists. It also works with the graduate student and the educator. And then later in the summer, so this is like 1-year program, and later in the summer, we get the undergrad student and also the high school student who join through this process. And you can learn more about this program there. Notice that this is the Goddard Institute for Space Studies, and this is the GIS. Notice that besides just doing research, so as you can see on the image here on the right, top right, so this is the team of our mentor and also the grad student, me. We also got the other undergrad student as well as a high school student. And at the bottom right, we have this poster because our research was actually presented at the American Meteorological Society conference this year. So it's great because we got to use, so we got to present about the Earth observations to improve the urban resiliency planning for extreme heat in Chicago. So that was part of our research here. And so as the educator of this program, I also get to share about develop this STEM curriculum portfolio. And as I go through this, notice that this portfolio is the unit plan that I'm going to be talking to you a little bit more now. So here's some images that we have. So this is our team doing research and collaborating together. So I really wish I could show you some images about, we're out there in the field and we are, taking some measurements, but you'll find out why, because we actually focused a lot into coding and using satellite imagery. So most of this was actually in the computer. It's not necessarily that we're going outside. So these are some images. So this program overall, where it's at GIS, it focuses the research in exoplanets, also astrobiology, and climate change as a whole. So talking about the last one, which is climate change, notice that this is the focus for our group. Notice that when it comes to this, it's important to highlight that cities across the globe are experiencing increases in the frequency and the intensity of hazards, such as, for example, droughts, tropical storms, hurricanes, extreme heat, floods, and on. So this is a problem that we're experiencing. When it comes to climate change, that's a situation that we're going through. And they are facing challenges as the global climate continues to change. In fact, more than half of the world's population currently lives in cities. And this is actually projected to increase as we go through time. By 2050, it is estimated that 2/3 of that population will be in cities. The problem is that we are dealing with some infrastructure problems. It's not just our cities we're not designed to deal with all these changes that we're going through, and as a result, that's a big problem. And previous urban planning efforts did not plan for the projected climate extremes. So this is, as you can see here, this is from the Urban Climate Change Research Network, this map that you can see here on the right, and we have this opportunity to talk about just the population of metropolitan areas. So as you go through metropolitan areas, notice that here we have a population of those. So it goes from mega to large, big, intermediate, small. And if you look at those numbers, even the very small city, actually, it's still big, right, in population. So I think it's important that we have to prepare for that. And one of the challenges that we have faced is actually to make sure that we are doing something, specifically when it comes to the temperature, global temperature changes. So as a result, our research for our group is our goal is to use Earth observations to inform urban planning efforts in order to mitigate the impacts of climate change in cities. So as we go through that, notice that the research question that we have is actually, how can Earth observations be used to help cities improve resiliency planning that can mitigate adverse outcomes associated with extreme heat? And with that said, we have actually focused into different cities. So for example, Chicago, New York, and Durban. So in fact, the research that I was showing you earlier with the team, we have done research in Chicago. That was actually last year in 2020. And we have also focused into New York. And as of currently right now, we are doing some research in Durban, which is located in South Africa. So all of these are important cities that have developed their population. It's a high population or populated area, and they are going to experience some problems when it comes to climate change. So I think it's important also that we understand the urban heat island. So the urban heat island, if you haven't heard about the urban heat island, notice that it's pretty much related, as you can see here on the graph. Notice that on the y-axis, we have this air temperature in degrees Celsius, and we have a variety of different locations. So first of all, you know that when we have materials such as asphalt, steel, and brick, they are often very dark colors like black, brown, gray. So a dark object absorbs all the wavelengths of light energy and it converts them into heat. So I know that, some of you probably got the concept because you might teach this in your school, but the object gets warm. So in contrast, for example, a white object reflects all the wavelengths of light. So the light is not converted into heat, and the temperature of the white object does not increase noticeably. So in conclusion, dark objects, such as, for example, building materials, absorb heat from the sun. And this is what we call this phenomenon, which is the urban heat island. And as we go through here, notice that in this graph, we have these different parts of a city. So we start on the left with the rural, and then it goes into suburban, residential, commercial, then it goes into downtown and moves on into the parks, suburban, residential. So as you look at this line that it shows this trend, notice that you're looking at this, the temperatures are actually higher, so like 32.8 degrees Celsius, where we're talking about downtown, compared to other areas such as rural, for example, which is like 29.4 degrees Celsius when we're talking about air temperature. So there is definitely a difference between those. So it's important that we understand that this is actually with the earth temperatures, but we can actually even go into the next step and talk about the surface temperatures. So right now, we're actually going to watch this video. This video is about one of the satellites. So we can actually watch, so we can use, of course, we can go outside and we can use remotes. We can use just roving and taking some temperatures. But we're going to watch this video at this moment about a satellite, because we can use satellites to understand more about the temperatures like in the surface. So this video, which is from the USGS and Geological Survey, as well as NASA, of course. Let's watch this video so you can learn more about Landsat 8.
As we orbit the sun, Landsat 8 positions itself to capture imagery in direct sunlight. It's called a sun-synchronous orbit. And it happens every 99 minutes, and about 14 times a day. As Landsat travels from the North Pole to the South, it's capturing data over a 115-mile wide swath. So every day we add 14 swaths. And over 16 days, we complete a full picture of our planet. And we start the cycle again to watch global changes as they happen.
So that was an introduction into what Landsat is, in case you were not familiar. And Landsat satellite it helps us to understand how the world, how Earth works, and we can actually track temperatures, for example, through constant remote sensing data tracking, which it saves us time, it saves us energy as we go through this, because we don't have to be in the same place for days, months, or weeks, or even years to track temperatures. And satellites can now actually do that. So when it comes to satellites, we actually use Landsat data, and Landsat has different bands. So for example, it has band 10. It also has band 5 and 4. So those are the ones that we focused on. And notice that when we're talking about Landsat, we're looking at, for example, if you look on the left, so we got this Landsat 8, band 10. And what happens is that we use this, we convert the digital number to radians. So in our research group, we then converted the radians at satellite brightness. And on the other side, you use bands 5 and 4 in order to calculate the NDVI, which actually stands for the Normalized Difference Vegetation Index. And this helps to measure the vegetation health and the density that it's in that specific area that you're focusing on. Now, after that, we can actually calculate the emissivity, which is pretty much related to the concept that I was telling you about the urban heat island description of those black body objects, for example. So we can actually use this LST, or land surface temperature analysis, and we can apply this to all of the 3 cities that I presented to you just a while ago, such as New York, Chicago, or Durban. And by the way, you can do this in any city of the world with Landsat. data. So as we go through this, notice that at this moment, so we use remote sensing imagery, and this is Landsat 8. And when you look at this, notice that the bands that I was talking about, for example, it goes from band 1 through 11, but 2, 3, and 4, we're talking about blue, green, and red bands, and these have a specific wavelength. So when you look at this specific wavelength, notice that they also have a specific resolution, and it produces the image that looks something like the one on the right. So when you look at that, notice that we're looking at this. And then at the bottom, we also have this band, which is band number 10. And notice that this is actually thermal infrared. So when we talk about thermal infrared, this has, again, its own wavelength and as well its own resolution here. And it produces the image that looks something like that. So on the top, we have the red, green, and blue. And so bands 4, 3, and 2. And at the bottom, we have band 10, which is like thermal infrared. So the idea is that eventually you get something that looks like this. We want to definitely look at the thermal infrared, but also at the remote sensing imagery from Landsat. So the next after, basically, just to give you a hint, when we're talking about this imagery, the raw data comes like this. So it just comes like a variety of different pixel numbers. And notice that this is how it's represented as we look at this. Now, the methodology, this is how it works. Notice that we have Landsat 5 image, which looks like on the, so let's go from the left to the right. So we look at this image. We also have the shape file. And by the way, this is Chicago. And the next step after you have the shape file is that you overlay and you extract that. And it produces an image that looks something like this. So notice that eventually you can get a mask, Landsat 5 mask, as you can see on the right. And that's what we're focusing on. That's the product that we're looking for. So as a result, when we're talking about modeling this land surface temperatures, we go from the Landsat mask, which is all the way to the left. And then in the middle, we have the NDVI, which again is for the vegetation index. And we want to go into the land surface temperatures, which is on the right. So as we go through that, notice that our steps as we go through this is that the first step is to calculate the quantile values for each of the scenes. So we use R. If you're not familiar with R is a coding program that pretty much we use to calculate those quantile values. And then we also use the TIFF files from the land surface temperatures that were loaded into our GIS Pro. So we got our images, so our satellite imagery, and by the way, this is for everybody. If you are interested in getting satellite images like for any part of the world, by the way, for any country, any city, we use Earth Explorer. And notice that is, so we talk about Earth Explorer. That is where you can get them. And this is again from between USGS and NASA. So that's a contribution right there. So we got those TIFF values, TIFF files, and we load them into ArcGIS Pro, which you may probably be familiar as well, which is a program that it's used for imagery and mapping. And so we use to extract those attributes, and we extract only the pixels that were within each percentile range. And eventually we can get mosaic to a new raster. So how this looks, we calculate the percent change by using the final scene temperatures minus the initial scene and divided by the initial scene, and then we multiply times 100 so we can get those years. And the temperature, by the way, it's in Kelvin. So when you calculate the difference in the LSTs based on the percentile ranges, so for example, we got some scenes. And by the way, it says L5 because we use Landsat 5, just because in our research that we were looking at, we were looking at a past distribution of events. So the time periods that we were looking were like in the 80s and the 90s. So back then it was Landsat 5. And when you're looking at this, notice that we want to avoid negative trends. So assumption is that the LSTs are increasing and lower percentile is actually associated with the features, like for example, water or vegetation. So here, for example, this is Durban. So if you have never seen Durban, Africa, here's, we're making a virtual trip right there. And so this is Isipingo in Durban, South Africa, which is next to the ocean right there. And notice that we're looking at this area right here. We got vegetation, and we also got urban buildings, the urban part of the location. As we go through this, we can actually create this true color image as the one on the top left, and also the land surface temperature, which is the one on the top, the one on the bottom left. And we can also go through those percentiles. We can look at those green spaces, for example, like the one on the bottom right, or the urban coverage of the 88th percentile on the bottom, on the top right. So notice that here we got the different parts, and we can break this down into what we want to focus and what we want to research on, such as urban coverage, the green spaces, and so on. As we go through this, we can actually, we go from like 95 to 2006, and this was like the period of time that I was telling you, so that's why we use Landsat 5, because it's back in time. And when we look at this percent change per those 10 years, notice that the negative trends are set to 0. And because that represents no change. So if you look at the last three, what we did is we actually just changed those into 0. And when we get that, notice that we can get land surface temperature for each percentile. And this image was supposed to be moving and show you different parts of the location here. But notice that as you go through the percent change per 10 years, according to the percentiles, it will be showing you a different part in the map. So the projected land surface temperatures, this is important. Now, why are we doing this? This is important because when it comes to like learning about, for example, land surface temperatures, and for stakeholders, city councils, governments, so they can know where, in which locations of the city or in what part of the country, what parts of the states we are actually, there's going to be a high change of land surface temperatures. In fact, here, by looking at Durban, South Africa, we actually were able to project what the land surface temperatures would look like by 2050. And you can see right there, red, which represents 285, and it goes to like this purple areas, 317. Notice that this would be like by 2050, those areas that would be more prune and just like more into the areas that we should take a look into because of the land surface temperatures would be higher. Now, this research was also brought into unit plan. So how can we use the research? How can we use remote sensing, satellites, imagery, land surface temperature, all of this to bring it into the classroom? Well, this was actually put into a unit plan. And this unit plan is actually made of 4 lessons, including making Earth cool again and what's happening to the Earth, to climate. So we're going to watch this video at this moment. The video that we're watching is actually from the global temperatures. And this is a resource that I think it's so powerful. So as you can see here, this is from, it's showing you the global temperatures of since 1884. You can see the description here all the way to 2000. So I'm going to play this. And as you're looking at this, notice that this color-coded map shows a progression of the changing global surface temperatures since 1884. And the dark blue indicates just those areas that are cooler than average. And the dark red indicates those areas that are warmer than average. So notice that as we go through time, and I'm just going to move closer. Notice that it starts to show some yellow in the 70s. And then as we go into the 80s, you can see more yellow. We're approaching the 90s now. We got some red on the top. And notice that this goes all the way to 2020, the most recent here. And it is scary. It's scary to see what's happening here on the top. And notice that you can go back in time. And one of the things that you can do with this resource with your students is that you can have students look at that. You can also have students look at the carbon dioxide levels and how, again, there's a description at the bottom, and you can see how, for example, this has changed. So, for example, from 2002, and we're going to bring this, just fast forward all the way to 2016, and notice how the carbon dioxide levels have changed. You can also look at the sea level, how it has changed, what the research projects, how it's going to change over time. And you can see, for example, that this is going to be affected. And as well as, for example, the last one, which also you can look into, besides the sea level and the other three, you can have students look into the sea ice. And you can see this is a representation of the visualization that shows the annual Arctic sea ice minimum since 1979 up until 2020. So these are some of the tools where you can have your students look at the temperatures and how they have changed. And at this moment, we're going to come back to the presentation. But as we go through these resources, notice that here we can, so this unit, this first lesson that we're looking at, this lesson focuses into that. So in the first lesson, students are engaged, they're exposed to climate change, how it has happened, what it involves, the evidence for climate change. And one of those resources, as you can see, it's actually this global climate change temperatures that I was showing you. And there's more, not just that, but students are exposed to identifying the locations that have been altered by climate change. Also, they make sense of how climate change has been changing and what that means for us and the world. So students are actually interpret and they analyze satellite imagery, and they create a poster about the location that has been affected by climate change. So that's just some of the things that you can actually find there as we go through this here. But notice that there's another resource. So we're going to watch this video now, which talks about the images of change, which is also part of lesson 1. And as you're looking at this video or this website, which is called Images of Change from the Global Climate Change, notice that this shows how basically like the before and the after. This happens to be from the invasion of water hyacinths across Valsequillo Reservoir in Mexico. So the cool thing is that it's so interactive, and students can actually scroll to the left, scroll to the right. You can read a description of what this means, what this place represents. So notice how it shows how the community or the plants has been affected. You can download the images if you want to show them. It shows you the map on the right so you know where in the world we're talking about. And there's a ton of images that you can use. For example, we got here the Greenland's Spalt Glacier, where it disintegrated. And you can, again, students can scroll from the left to the right. And notice that this is such a powerful tool. This is where like one of the most easiest and powerful tools where students can actually get exposed into how to see that. So there's a lot of different images. Notice that if you click on here on the 4 squares right here, you can actually get, so like if, let's say you're interested in finding an image from any other part of the world, image of change, which shows the before and the after due to climate variability or climate change. You can find it from whatever you want, and you can just click there and you will be able to find. You can also select, for example, if you want to go from, so like the cities, like specific city, and it shows you are like extreme events, or like if you want to focus into ice, images or human impact images, water, land cover. So there's just a ton of those images that you can talk about. Now, we're gonna come back to the presentation, and I'm gonna show you about lesson 2. When we talk about lesson 2, notice that this focuses on seeing from another perspective through the use of satellites. So satellites, like I was telling you, like I show you this video from Landsat 8, when students are going to look at satellites and just define remote sensing, what it is, what it represents, they're going to read about Terra, which happens to be one of those satellites that I have students focused on. They get to learn about different instruments that it has, investigate how climate satellites from Earth Now platform are, and they get to analyze and explain just the contribution to climate research. So students probably are not familiar with climate satellites. So this is a breakdown where students not just learn about climate change, but they actually learn about satellites and what they represent, their instruments that they have. So we're going to watch this video about Earth Now, where you can actually see this website it's actually called Earth Now, this is one of the coolest websites that I have seen, where you can actually see the satellites, specifically just the climate satellites, in real time, how they look. This is, again, you can just this works, by the way, on 8 tablets as well. So you don't have to use a computer for this. It works on phones as well. Notice that all of these are the satellites that you can see here. And so you can see the satellites now. So how do they actually look at right now in this part of the world? And also, you can see how they are moving through as well. So as you look at these satellites, let's actually look for, and by the way, the International Space Station is right there. So let's go into Terra. As we go to Terra, notice that this is how Terra looks like. And you can have students actually look at how Terra satellite looks like. And when you look at this Terra satellite, notice that you can learn more about the missions, like the time in orbit. You can look at more information about Terra. Notice that it shows the instruments that it has, such as MODIS, Aster, and so on. And this is such a great experience because students get to learn the images. So if you can animate, so you can have students animate this data or images from Terra satellite. And notice that it shows them, they can choose the timing from when you want them to focus on. So coming back to here, let me show you, for example, we can also, another part of this website, which you can find, for example, when you click on those instruments right here, notice that it takes you to the website from NASA where you can learn more about those, just these different instruments. So you can learn about Terra, the satellite, you can learn about Aster instrument, you can learn about which series, which focuses on the clouds, MISR, which focuses on the spectroradiometer, and MODIS, which is like the motor resolution of spectroradiometer, and MOPIT, which focuses on the pollution of the troposphere. So it depends on what your interest is about climate change. You can have your students just look at a variety of different resources here. And notice that there's other parts that you can see. So you can look at the Earth temperature here globally, and you can have your students just look at different time sets. So day average, whether if it's that or any others like that. So you can look at the carbon dioxide as well. You can choose the dates where you want, and you can animate. So this is a great tool to have students learn about this. So we're going to come back to our presentation, and we're going to move on into lesson 3. So when we talk about lesson 3, as we go back to our presentation, lesson 3 focuses into the urban heat island and its effects. So this is focused on when heat is trapped, what happens. So in this lesson, students they get to observe imagery from remote sensing satellites, and they get to make connections. So the idea is not to tell students that when there's a vegetation area, that is different from when there's urban, but have them through inquiry-based experiences, have them make those correlations. And then it leads to students investigating about the urban heat island phenomenon, creating a poster, explaining what they just learned, investigate and download remote sensing from Earth Explorer. So basically the research that I was telling you about, it's not just scientists do this, but actually you can have your students download those satellite images and have them compare. So for example, and we're actually going to move on into the video for that it's next. So in this here, notice that this is part of my unit plan. So when you actually go into the unit plan lesson 3, you have students look into remote sensing images. So this is New York, and notice that we have the temperature here, that it's warm. It's also hot. And you can also see I presented the vegetation here. Concept. We got, I included about 5 different cities. So we have Atlanta, for example, and Atlanta actually has like this Landsat image, but also that we have this temperature, the same picture, just from a different perspective. So notice that this is such a powerful way to see these different cities. This happens to be Baltimore, which is, again, we have this land surface temperature here on the top. And then if you, as you move on, you can actually see the temperatures, the brightness temperatures there. And there's more images. For example, here, the last one that I'm showing you, it's for Providence, Rhode Island, where you have this aerial map, but also there is this, just this map, which shows the brightness as well. So we're actually going to move on into the next website that I want to show you. So another resource that I include in this unit plan is actually the Earth Engine. So Google Earth Engine, this is a platform that it's also very easy to use. Notice that this is from the Earth Engine app, and this is such a great resource because like you can look, by the way, this works everywhere on Earth again. So like if you want to use it for any specific place on Earth, what you do is like it shows you the urban heat islands, and the temperatures of those land surface temperatures. And you can see, for example, you can focus in on these resources, and you can just like find whatever you want to focus on. So for example, if you're interested in seeing the aerial summer day, for example, or if you're interested in seeing let's just look at the annual day. Okay, so average annual day. And again, right now, this is New York. And notice that you can go back in time. So how, for example, it used to look, I don't know, 2003 or before, or how it used to look like as of 2017. And probably you can have students compare. How did it change from back then, a decade ago, into today? You can see it in satellite view. You can see it in different views. And the cool thing about this, it's not just the map. But you know what? You can actually have students click on the area of interest, and it provides you this information like latitude, longitude, the annual daytime, UHI, urban heat island, the winter daytime, and the graphs, which I think is so incredible because like you can have students look at those annual daytime, UHI, the daytime, the nighttime, how do they compare through time? And this is in the degrees Celsius, and you can just do this anywhere. One of the things that I have my students do, it's do this in like where we are. So for example, right now I'm showing you New York, but you can have, if wherever you are, you can show your own place, but also maybe you have students from another country, maybe you have students from another place, and this is so good. So you can actually have them compare, hey, so how does it connect to where we are to the country where you are from or where you have family members from? So we're going to come back to our presentation, and now I'm going to dive into our last lesson, which actually focuses into lesson number 4. So notice that as we go through this one, lesson number 4 focuses into the changing land surface temperature. So basically, this is where students can actually do the research. So just like they were able to see it on the computer, on the maps, now they get to do it on their own, where they get to record, go outside, take temperature recordings from like vegetated areas, asphalt areas, and use infrared thermometers to record those temperatures, collect that, and we use this through a platform that it's known as a globe. So if you're not familiar with globe, we're actually, let me show you on the next. So let's watch this here. This is actually the GLOBE program. And as we go through the GLOBE program, notice that you can actually access this website. This is so good. If you have never seen this, I really invite you to look at that. You can learn more about there. You can get trained to become a GLOBE teacher, a GLOBE school. There's a lot of different things. You can do GLOBE. Now, why is this important? Because think of this like a community of schools, students who are recording data, uploading their data, and also using that data to do research from different parts of the world. So just like you can have your students do data, you can actually do that. I'm going to get into this visualization system, which is right there. And again, you can do this on the whole world. And it's so easy to use that I'm going to show you here in less than 1 minute. So the first thing is to show you, it's look at those dates. So for example, we got the dates that, let's say we want to go from, and it goes to the 90s or even before. So let's just say I want to look how it goes from 2006, for example, to there. The next step is actually to go and select what you want. There's different parts like the atmosphere, biosphere, the hydrosphere. So at this moment, let me just go into the, let's go into the first one. You can look into precipitation, clouds. I want to look into the surface temperatures. So when you click on the surface temperatures, notice that you can just click submit, and it's going to take a few seconds, and it's going to populate all the recordings from different schools and institutions where they have actually done this. So for example, let's go to Spain. And when we actually go to Spain, we can actually click on this school and we can actually get some data. Notice there's a description for this school setting. And also notice that there is, so we have different data, and you can look at those measurements. You can actually download those measurements, and you can even see, for example, if you're interested in seeing how the clouds were in that area for those times, or how the earth temperature was in that area for those times. And the cool thing about this is that it's not just about like what other people, other schools have done, but you can also do this in your school setting, as I told you. So as we come back to the presentation, I do want to say that even in pandemic times, like I was telling you, science doesn't stop, because I have done this with our students. Notice that we are actually, so there's face masks right there, but it was such an engaging and just a very exciting opportunity for students to do research. So this is something that you can do in your school. So you can actually take the temperatures, for example, from vegetated areas at your campus or surrounding areas, and also from just other parts of the school. This project ends with, or this unit plan ends with the capsule project, where you have students build a model of the urban heat island effects. And notice that it's, for example, this is one of that we have done. And notice that it has buildings, the streets, and so on. But notice that I have students also talk about the mitigation aspects. So for example, if you look at here, this is actually the same model, but with like green roofs. And notice that there's some aspect for just the solar panels that you can see. So we want to basically transform, how can you transform the cities into something that can be definitely a mitigation aspect for urban heat island and those big cities, as you can see here. But it's not just about making a model, but it's also like having them download satellite imagery through Earth Explorer, and also looking at those, like I was showing you from Google Earth Engine, get the data and reflect on how that has changed over time. So I do want to say that this unit plan was actually, it involves lots of next-gen STEM resources. It has pre and post assessments. It has real-world scientific experiences. It aligns with the next generation of science standards, as well as other standards, including the NASA's mission, vision, STEM resources. This was actually presented at the American Geophysical Union, and you can see the poster on the top right, as well as in the Space Exploration Educators Conference just at a couple of weeks ago. And this has been reviewed and published by NASA Science Mission Directionate, so you can actually know that this is like official. So with that said, I do want to thank you, and I want to acknowledge the different people that have made this possible.